Hi, everyone. Today we'll we'll complete the chapter that we started in the previous session by introducing a new term, probability for multistage events. What we mean by multistage event, as definition, a multistage event is one that is made up of simple events such as tossing a coin and rolling a die one after the other. Finding probability in this situation is made easier if we use table, tree diagram, or lattice diagram to show all the possible outcomes and to find the element of the sample space that we are willing to work in. Okay, so normally multi-stage event consists of two or more simple events, as we said before. For example, tossing a coin and throwing a die. Okay, so you should know that the result of the first event may not, in general, may not affect the result of second event when we are talking about independent events. So let's start. A bag contained 3 red discs and 1 green. So we have in the back, we have 3 red discs and 1 green disc. So we have a coin is tossed before with the first event. The second one is a disc is chosen. So normally coin is tossed, so we can obtain firstly head or tail. If we obtain a head, so we go to apply and for example, and to perform the second event. Okay, when performing the second event, we want to choose a disc, and we have in the back we have a 3 red, 1 green, so we can obtain a red or red or red or green in the same way. Even we obtain the tail in the first event as a result in the first event. Second event, the result should be the same, red or red or red or green, because we have a red disc have a weight more than green disc. We have a 3 disc to 1 green in the same bag. So the sample space could be given by these outcomes: HR, 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 HG, TR, 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 and TG. Okay, and of course, the first letter represent the outcome of the first event, the second one for the second event. Okay, so we use an organized method to combine the outcomes of each simple event. As we said before, for example, this method is very organized and is called the tree diagram. And how to calculate the probability? The probability here equal to the number of favorable outcomes over the number of possible outcomes. The number of possible outcomes equal to the total number of the outcomes in the sample space. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the total one. And what about we want to complete to find the probability of getting tails and red disc? Tail, so normally we are interested in this branching, and red disc, 1, 2, 3. So these 3 outcomes answered this question. So 3/8. Tail, as we said before, complete to find the probability of getting tails and the red disc. Total number of outcomes equal to 4 plus 4. No, we have totally, we have total number. Okay, the total number of outcomes, 4 plus 4, 8. Okay, and we have a 3, so normally 3/8. Sorry, this is the answer of the total outcome that we explained before. So when we count all the number of outcomes in the sample space. Okay, moving on to the next exercises, you can also assess yourself by solving the question without answers. Okay, we have a jar contain 2 red discs and 1 blue disc. A coin is tossed in the same way. We have a coin tossed, so we can obtain head. We can obtain a tail. Okay, we have a 2 red and 1 blue. So normally the second event could be the result of the second event, red, red because we have two reds, and we have one blue and blue. And also, if we obtain tail in the first one, we can obtain the same outcomes that we obtained if we obtained before as head and the blue. So the outcomes are, we have 1, 2, 3, 4, 5, 6 branchings. So normally the sample space consists of 6 different outcomes. Okay, so normally, or we can represent, instead of using the tree diagram, we can use the table. The table could be organized in this way, head or tail. Okay, and for head, we could obtain red or black or blue, and for the tail, the same. Okay, normally, if we are searching for the outcomes in the sample space, so HR, HB, TR, TR, TB, okay, the total number of outcomes is 6, and also they ask to find the probability that the result is a head and a red disk. Head and red disk, so normally we are interested in had red disk. So 2/6 after simplification, we will obtain 1/3. A head and a blue disk. A head and the blue disk, 1/6. A tail and a red disk. So tail and red disk, so 2/6, equivalent to 1/3. Easy to also to calculate the following one. For example, here it is more complicated because the outcomes becomes more numerous, and representing it in an organized method become more complicated. For example, a bag contains 2 green discs and 1 black disc. A die is rolled and a disc is chosen at random. So a die is rolled normally will obtain 1, 2, 3, 4, 5, 6, and then a bag we will obtain G green or black. I think we could for example, start by 1, 2, 3, 4, 5, 6, and then G, B, GGB as follow to only to work in the same order, because they said a die is rolled and a disc is chosen. It's not big deal. So the sample space are given as G1, G2, G3, G4, G5, G6, and so on. In total, we have 18 different outcomes as elements of the sample space. And if they ask us to, for example, to calculate the probability of cutting a tree and green disk, 3 with a green disk, a green disk with a 3, we have a 2 green disk with a 3. We have only 2 outcomes, so 2/18. For example, a 5 and a black disk. 5 black disk, we have a black disk with 5 only once. From 18, and odd number. Odd number, we mean like 1, 3, 5, and so on. So odd number with the green. So with green, for the first green, we have a 1. Odd as an odd, we have a 3 with it at the odd, and the 5. So we have a 3 different outcomes here and different 3 outcomes, 6/18. And an even number and a black disk. For the even number are 2 for the multiple of 2. So a 2, a 4, and 6. So normally B with 2, B with 4, and B with 6 are the outcomes that represent an even number and a black disk. So 3/18, and so on. Also, we can use what we said, the net diagram, or differently said, is given a different number, like notation, or we can denote it by lattice diagram. So lattice diagram is very easy way, also well organized, to represent the outcomes of the multi-stage events. So the die one give us these different outcomes, 1, 2, 3, 4, 5, and 6. And second die give us also 1, 2, 3, 4, 5, 6. If we completed then the different numbers, we have a 1, 1. This point represent 1, 1. 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Why we started by this one? Because this is the first die and this second die. So we started by 1, then this number, 1, 2, 1, 3, 1, 4, and so on. So complete the calculate. Normally, it is very obviously that we have 6 by 6. We have 36 outcomes. The total outcomes 36. The number of favorable outcomes to obtain a 5 and a 1. 5 and a 1. In any order, we have 1 with 5, and we have a 5 with 1 with 5, and a 5 with 1. So normally it is only 2 over 36. A double. Double, we mean all the outcomes on the main diagonal. Why? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. All doubles. Doubles. So the same number is obtained in the two events. So the number of 5 favorable outcomes equal to 6. 6 over 36 after simplification is equivalently equal to 1 over 6. Okay. And also for example, the study or the experiment could be can consist of more than 2 events, 3 events. For example, they ask us the 3 coins are tossed. The first coin, when the first coin is tossed, when the second coin is tossed, when the third coin is tossed. Normally, we can obtain by tossing a coin head or tail. Similarly, head or tail, similarly, head or tail, and so on. So in total, the total number of outcomes equal to 8. And we have like 8 branchings, okay? 8 branchings. And normally, if we are talking about... and so on. And these are the important idea of this study. Thank you for listening, and sorry for disturbing you.